If k to the power of 1 over x is equal to 3, k to the power of 1 over y is equal to 4, and k to the power of 1 over w is equal to 12, prove that w is equal to xy over x plus y. So if you look at what we have to prove, you'll notice that w is the subject. So the only equation that we have with w is this one. So k to the power of 1 over w has a numerical value of 12. And we're going to go ahead and make 12 the subject. And these equations, we have k to the power of 1 over x is equal to 3 and k to the power of 1 over y is equal to 4. So we have to see how can we form 12 using 3 and 4. Well, we could say that 12 is equal to 3 multiplied by 4. So in place of 12, we can replace that with k to the power of 1 over w. And this is equal to, in place of 3, we can replace that with k to the power of 1 over x. Multiplied by, in place of 4, we can replace that with k to the power of 1 over y. So now on the left hand side, we just have k to the power of 1 over w is equal to, here we have k being multiplied by k. When our bases are the same, we can go ahead and add the exponents. So we'll keep the base the same, we still have a k to the power of 1 over x plus 1 over y. And now we have an equation with our bases being the same. When the bases are the same, you can go ahead and equate your exponents. So we're going to make the exponents equal. So therefore, 1 over w is equal to 1 over x plus 1 over y. So in what we had to prove, we see that we have a w as the subject. So we can leave this on this side, and we're going to have a 1 over w is equal to, and we have to add these together. So 1 over x plus 1 over y. When we're adding fractions, the denominators have to be the same. So to make the denominators the same, we can simply multiply 1 over x by 1 in the form of y over y. And we can multiply 1 over y by 1 in the form of x over x. And now we'll have 1 multiplied by y, which is just y over xy, plus 1 multiplied by x, which is x over xy. And now that our denominators are the same, we can go ahead and add them. So we just have a 1 over w is equal to, and we'll keep the denominators the same, and we'll have a y plus x. Now, if you look in what we have to prove above, the w is on the numerator, but here our w is on the denominator. And since we have a fraction here and a fraction here, and an equal to sign in between, we can simply cross multiply. So we're going to say our w multiplied by y plus x, which we can just write as w multiplied by y plus x, is equal to 1 multiplied by xy, which just stays xy. Then we want to make w the subject, so we can divide both sides by y plus x. And so when we divide by y plus x, we're going to have our y plus x cancel out here, and we're left with a w is equal to xy over y plus x. And this is the same as what we have to prove, just that the x is first. So if you want, you can go ahead and put the x first. So w is equal to xy over, since the x is positive, you can put it in front, and the y is also positive, so it's a plus y. And there we go.